Hello, hello everyone. Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 1653 minimum deletions to make a string balanced. Okay, the problem statement states you are given a string S consisting only characters A and B. You can delete any number of characters in S to make S as balanced. S is balanced if there is no pair of indices ij such that I is less than j and s of I is equal to b and s of j equal to a. Okay, there should not be any pair with this particular combination. Okay, return the minimum number of deletions needed to make s as balanced. Okay, how can we make the string balanced? Let's take the same example over here. Okay, so let's say I'm trying to process my string in this particular direction. Okay, I have encountered a, that means so far there were no B's and I've encountered a, that means I don't have to do anything. I will simply go ahead. Again I have encountered, I don't have to do anything. I will simply continue. The moment I have encountered B, okay, either I choose to delete this B and get the answer from the rest of the string, or if I keep B over here, that means there should not be any A in the remaining string. Okay, because if I keep at least one A in the remaining string, that means B comma A pair will be formed. That means that is violating our definition of balance. Okay, so for any given position, if I encountered B, that means either I can delete the particular B and get the answer from the remaining string, or if I keep B, that means I have to delete all the A's from the rest of the string. So I should know, somehow I should know the count of A's in the rest of the string. Okay, let's say we know the count of A's for the rest of the string. Okay, then the answer will be simply the number of A's in the rest of the string. Okay, so we know for a given position there were two possible options I have, and there can be different answers from both of the options. So the overall answer will be the minimum of these two, because we are trying to minimize the answer. So if for a given position, okay, the best answer will be taking the minimum of both of this. Okay, so let's try to derive a recurrence relation based on our understanding. Okay, let's say I have a function f which will take an index I and which will also take the count of A's in the given string from I till all the way till the end. Okay, let's say I have a string with and I am trying to process at index I, and I know what is the count of A's in the remaining string. Okay, so if at the current position, if the character is A, then I don't have to do anything. I will simply go to the next position and I will get the answer for it. Okay, which will be f of I plus 1, and the count will reduce by 1 because we are going to the next string, and the overall count will be reduced by 1 because I have removed this A from our current string. So the overall count will be reduced by 1. Okay, and if the character at I is not A, that means the next possible character is B. Okay, if the current character is B, that means I have two options, either to delete B or to keep B. If I choose to delete B, that means there will be one deletion. Along with that, I have to get the answer for the rest of the string. Okay, so using this I can get the answer for the rest of the string. If I choose to keep B, that means I have to delete all the A's from the rest of the string. So that will be the count of A's. Okay, so using this recurrence relation, you will be able to get the answer optimally. Okay, if you draw the tree diagram for this, you will notice that there are certain overlapping problems. Okay, whenever there are overlapping problems, okay, that means we should use dynamic programming. You will notice that the states are repeating. Okay, so whenever the states are repeating, you don't have to recompute those states again and again. So we will be simply caching those values and reutilizing them again. Okay, so let's jump back to Leetcode and let's see how I've implemented. Okay, so I've just defined two variables at the class level, which is s and dp. As I mentioned, the states will be repeating and we should also cache those states, so that is why I defined a dp. Okay, dp array. So I'm just setting my string to the class variable, and then as I mentioned, I should know the count, right? So whenever I'm starting my function call, I should know what is the overall count of A's I have. So I iterated through the entire string and then identified what is the counts of A. Now I should also populate my DP array with state -1 to indicate that the answer for all these states is not calculated yet. Okay, so here I've defined the function as f. So for better readability, I have defined a function called min deletions, which will take an index I and which will also take the counts of A in the given string. Okay, so if the current character is A, that means I will simply go to the next position and get the answer for it. Since this at the current position we have one single A, the overall counts of A will be reduced by 1. Okay, if it is not A, that means automatically it is B. That means I have two options, either to delete it or to keep it. When I choose to delete it, it will be 1 plus this particular value. If I choose to keep it, that means I have to delete all the A's from the rest of the string. So that is what we have here. So when there are no characters to delete, okay, then I will be simply returning 0. So this is the base case for our recurrence relation, and this is just basic memoization which I have done. Okay, if I already have answer to the current state, then I will be simply returning it, or else I will be computing and storing it in the value for the future use. Okay, so let's try to submit this problem. Okay, as you can see, all the test cases were passed and it is pretty efficient solution as well. Okay, let's try to analyze the time complexity. Okay, I want you to analyze the time complexity of this algorithm and comment in the comment section, and what is the space complexity as well. Okay, I want you to analyze the time complexity and space complexity and comment under the video. Okay, so let me analyze this time complexity and space complexity for you as well. So as you can see, we are just iterating through the entire array so one time. So this is big O of n, and we are also trying to compute the states of n states basically. So the overall time complexity is big O of n, and the space complexity is also big O of n, because we are storing the states. Okay, that's all about this problem. I highly recommend you to subscribe to my coding channel so that you won't be missing the content which I will be posting on daily basis. Hit the like button, hit the subscribe button if you like the video, and also share your valuable feedback in the comment section. And also don't miss to implement this solution in the bottom up fashion as well. I have shown you in the top down fashion, and I highly recommend you to implement the bottom up approach as well. Okay, that's all about this problem. Thank you, and don't miss to subscribe to the channel.